Hello, my name is Haoyu, and here's homework 8, question number 1. So in the question, we're given x of t is WSS process with x of t, e of xt equal to a constant, and rx of t1, t2 equal to rx tau, where tau equal to t1 minus t2. And the yt equal to a derivative of xt. So we need to find out first the e of yt. E of yt is equal to, we know in the question we know yt equal to x derivative of xt, so we can get here e of yt equal to e of x derivative of xt. Then we can get the e of derivative xt equal to derivative of dt d divided by dt times e xt, which is d over dt, a constant, which is 0. Second small question, we need to find out e of xtyt. It's the same. We can get it here. E of xtyt equal to rt1, rt2, and e of xtyt equal to e of xt x derivative of ext times derivative of xt, which we can get here is equal to d over dt e of x squared t, which is, now we do the derivative, we can get here 2ext over t 2ext times derivative of xt, which we can get here rt1 t2 is equal to r tau. R tau is equal to t1 minus t2. Then we can get r0 here. Then we put 0 back in here. We can get the answer is 0. For the third and the fourth questions, it asks us if RT and YT are uncorrelated and orthonomial. So we can get here, which we know e of xt derivative of xt equal to e of xtyt, which is equal to 0, is also equal to e of xt times e of yt. So which know xt and yt are orthogonal and uncorrelated. In second questions, we know the Haoyu process with parameter lambda. We are telling this, and here's the graph. We need to find out p of xt equal to 1. So here, so we know e to the lambda t equal to 1 plus lambda t plus lambda t squared over 2 plus this, and we regard this as equation 1. For the e to the negative lambda t equal to 1 minus lambda t plus lambda t squared over 2 minus lambda t to the 3 over 3 times 2 times 1. Then we do the equation 1 minus equation 2. We can get the e to the lambda t minus e to the negative lambda t equal to 2 times the lambda t plus lambda t to the third over 3 times 2 times 1 plus lambda t to the fifth over 5 times 4 times 3 times 2. So we can get here when p of xt equal to 1, we can get it's p of 0 t and the k is equal to odd. Then we can get the sum up from k equal to odd, e to the negative lambda times lambda t to the k over k. We can get it here. Then we can get this equation. We calculated this equation, we can finally get 1 minus e to the negative 2 lambda t over 2. So we do the reverse way. For equation 1 plus equation 2, we can get e to the lambda t plus e to the negative lambda t equal to 2 times 1 plus lambda t squared over 2 plus lambda t to the fourth over 4 times 3 times 2. Then we can also get here, it's basically the same as this one, but k is equal to even. And then we can finally get e plus 1 plus e to the negative 2 lambda t over 2. In the second questions, we need to find out e of xt. E of xt, which is here, it's 1 times p of xt equal to 1 plus negative 1 times p of xt equal to 1, which we know when p of x of t equal to 1 equal to this equal to this 2, and we just plug back in here, we can get this, and we do the calculation, we can get negative e to the negative 2 lambda t. For the next questions, we need to find out RT1, T2. So we make an assumption first. For T2 larger than T1, in the graph we can assume here T1 is equal to this, T2 is here, which is to the 1, and for T1 is here, T2 is here, we can get negative 1. So if we want to find out RT1, T2, we can get here e to the xt1 times the xt2 equal to 1 times p of xt1 times xt2 equal to 1 plus negative 1 times p xt1 xt2 equal to negative 1. Then we do the calculation here. We can get the answer is 1 plus e to the negative 2 lambda t2 minus t1 over 2 minus 1 minus e to the negative 2 tau, or 2 lambda t2 minus t1 over 2. After that, we can get e to the negative 2 lambda t2 minus 1. Since t1 can either larger than t2 or smaller than t2, so we can just put the absolute value for t2 minus t1, or it's the same as t1 minus t2. So rt1 t2 equal to e to the negative t2 lambda times the absolute value of t1 minus t2.